Welcome to our last example from 11.6. This is number 40. I just thought it'd be wise to do one more type of example with you. Nothing earth-shattering here. We're going to be doing the exact same thing. And so, for lack of a better reason, I'll just do it by substitution. I'll go to that first equation since it's the easiest to solve for either y squared or x squared. And I'll make the determination, well, I can easily get y squared by just moving over the x squared and the 4. And it would be a positive x squared and a negative 4 when it gets moved over. What are we going to do next? Same thing that's been modeled. We're going to take our second equation and substitute in. And now you can see why we taught both substitution and elimination. Somebody may have left their linear experience saying, all we need is elimination. That's the fastest. But it's not always the fastest if you have nonlinear stuff. In fact, most often it would be that. Now, I made a mistake, didn't I? You probably saw that. My eyes went up to the first equation, so it was 2x squared plus 3y squared. And what have I forgotten to do? I've forgotten to square that y. Oh, nope, that is y squared. So I don't even need to do that. So that is my y squared. What I did do is go up and forget about getting the 6, right? And my eyes went up to the other equation. So that's what we have. Easily solved. 2x squared plus 3x squared minus 12 is equal to 6. 5x squared is equal to 18. So x squared is equal to 18 fifths. So x is equal to plus or minus the square root of 18 over 5. Let me make that above one look a little bit better because I had mistakenly put a 5 first, but it's square root 18 fifths. So totally could happen. So you're going to end up with some ugly solutions. I'm not going to rationalize it right now. I'm just going to see what works with this. How am I going to figure out what my y's are? Well, my y squared needs to be equal to x squared minus 4, right? So I'm going to use that. So let me take the positive one first, and I'll write it the same way we see it, so it's not confusing. What did we say x was? Well, we said x was root 18 fifths, right? And we're going to square that, minus 4. Not surprisingly, it comes out to be 18 fifths minus 4. So y squared is equal to 18 fifths minus 20 fifths. So y squared is equal to negative 2 fifths, and we got a big problem. This can't happen. There's no way that something squared would ever equal a negative in the real number system. So there's no solution coming from the positive 18 fifths. Well, let's try the negative 18 fifths. Y squared would be equal to negative square root of 18 over 5 squared minus 4. But the same thing's going to work out. We get 18 fifths minus 4, which is the same negative 2 fifths. Well, we got a problem. There's no solution overall. So the answer in the back of the book is that there's no solution. Hopefully from your linear experience, you know exactly what that means. It means that these two objects, now what are the objects? The top one is a hyperbola, and the bottom one is an ellipse. You should see that from your work in 10. Why a hyperbola for the first one? Because of the subtraction, because of the different signs, actually, would be a better statement. Y squared is positive, x squared is negative when they're on the same side. That's a hyperbola. This is an ellipse. It's not a circle because the 2 and 3 are different weights. So when the 6 goes underneath them, the x is going to have more of a pull. So it's an elongated in the x direction, just barely though, ellipse, and it's a hyperbola that is opening in the y direction because y is that main variable coming through. So that's what we have, these two things. And evidently that ellipse is right in the middle of those two branches of the hyperbola. As odd as that sounds, what must be happening is something like this in order for that to happen, where the ellipse is right in between. At this stage, they're not trying to pick things that you're familiar with, and so they're not asking you to graph it. But we can logically start to think about how could that happen? It would have to be a case like this, or the ellipse, because the ellipse is along the axis, so it can't just be turned or anything. So it's got to be something like that, where the hyperbola is just starting outside of the ellipse. So interesting. But how did we find it out? Not by pictures. That's pretty inefficient. We found it out by trying to solve and realizing nothing's going to work. Notice that we got an x, a legitimate x that could work coming through, but when we tried to find its corresponding y, there was none.